So we keep on going, and we've been going through several topics, and certainly there is something that is very interesting to pay attention to, which is the way technology sometimes can be really helping society for several reasons. There is an amazing project that I discovered some time ago, which is launched by United Nations, and more specifically by UNICEF and ITU, which is based, or we can summarize it saying that through artificial intelligence and machine learning, they are able to detect and connect all the schools around the world. And that's really beneficial. And basically, the goal is to offer that communities, that schools, that families everywhere in the world, many more opportunities in the future. That's why I would like to invite to join us in the stage to one of the persons leading this project, which is called Giga-UNICEF, who is Naroa Zurutuza. Naroa, please, welcome in.
Thanks, Pipo. Cool. As Pipo said, Giga is a partnership between UNICEF and ITU to connect every school by 2030, to connect them to the internet. Let me start. And this is not a error, as they were asking me in the backstage right now. This is a spreadsheet, an Excel sheet, or a CSV file by default. Can anyone guess what type of information it contains? If you check up there, it has information about the schools. It has information about school names, about their location, and additional data about schools. Perfect, cool. We'll get to this in a second again. Changing topics and subjects, let's come to geography now. Does anyone know what's this? Again, it's a map of Brazil, and in particular, a map of the Amazonas region in Brazil. The Amazonas, it's the biggest state in Brazil. It's the largest one, and probably when you think of the Amazon, you'll think of jungle, of forest, of green, of fauna, flora. And of course, it's that, but it's also a region where 4 million people live. Most of them live in very remote areas. Even if you go to Manaus, the capital city of the Amazon in Brazil, and if you want to go from Manaus to Sao Paulo, Rio de Janeiro, any other city in Brazil, you have to go all the way from Colombia, Peru, and come back to Brazil. There are no roads that connect Manaus with the rest of the country. There are villages where you have to travel by boat up to 9 days to get there. In particular, this village, I was there in 2016. I had to take a private plane for an hour and then a boat for another hour. Once you get there, there is no mobile coverage, no 2G, no 3G, nothing. And if there is an emergency or anything, there is no way you can call and ask for help. And of course, there are schools here in these communities and in these villages. But oftentimes, the issue is that there are not enough qualified secondary teachers. Primary, it's more or less fine. But for secondary, it's an issue. And it's also an issue, the fact of bringing content to these places. When I was there, students and children had books with skyscrapers, with apples, objects that they don't relate to. But a fascinating thing that I saw there is that a student, thanks to a program from the government of Brazil, had access to education remotely, secondary education remotely. They had this satellite dish. This is active in over 2,000 villages and communities in the Amazon. They have a satellite dish, and thanks to that, 2-3 hours a day, they are able to get real-time education from Manaus, the capital city. This is the other side. So this is the production studio in Manaus, the capital city, where you have trained teachers that are able to provide and deliver content to students that are able to learn relevant content and then decide whether they want to go to university, whether they want to stay in their community, or what to do. We were inspired by this initiative and by this program, and we thought, wouldn't it be great if every school in the world were connected to the internet, and students all over the world, even in the most remote places, were able to access the most up-to-date content, but not only that, also access other digital services. That's Giga. Giga's mission is to connect every school by 2030 to the internet, and through that, connect every young person to information, opportunity, and choice. Because by connecting schools, you don't only connect the school, you also connect the community that lives around the school to the internet and to basic digital services. How do we do that? let's start with the Amazon and Brazil example. If you were someone at the government of Brazil and you were tasked to connect all your schools to the internet and you were given this map, you probably wouldn't know where to start or how to do it, right? Cool. And then let's come back again to the initial spreadsheet. If you were given this piece of information, you probably wouldn't be able also to properly connect, or you wouldn't know how to tackle the problem. And by fact, this is how usually government ministries handle this type of information. But if you start combining both of them, suddenly you can start understanding things better. So this is a combination of the Brazil map I showed with the spreadsheet I showed. And this is how digital inequity looks like in Brazil. Every dot here is a school. Red dots are not unconnected schools, and green dots are connected schools. And you can see that, or clearly you can see that the unconnected schools are in remote areas. You clearly see that the Amazonas region is predominantly red, whereas Sao Paulo, Rio de Janeiro, other places are green. But it's also a map of poverty, because oftentimes red schools are in poor areas, and green schools are in rich areas. So this map starts to tell us many more things beyond information about the connectivity. If there is an emergency, if there is an outbreak, if there is an epidemic, it's usually harder to reach the unconnected places and the red schools. That's also where the most vulnerable children live, the ones that UNICEF tries to serve, and usually they are the hardest to reach and access. This is a map that Giga is building. If you go to maps.giga.global, you'll see this map live. It's a public open map. It's the largest open map of schools that's updated in real time. Here you'll see some dots that are glowing, so that means that these dots and these schools are transmitting in real time their quality of service, the information about their connectivity, upload speed, download speed, latency, and others. Giga is able to see this in real time. We know when a school gets connected, we know when a school gets unconnected or internet stops working, and we can start using this information to address the problem. I talked about Brazil. The reality is that this digital inequity looks very different depending on the country. There are countries like Brazil where 88% or above 88% of schools are connected to the internet. And you may think that, OK, that's not so bad, right? But then if you start thinking about the size of Brazil, there are around 125,000 public schools in Brazil. It means that there are still many schools that remain unconnected and many children that remain unconnected. There are other countries like the OECS, the Eastern Caribbean islands or states, where 100% of their schools are connected, but still, the problem doesn't end there. The issue in the OECS is quality. The quality is not good enough to be able to properly conduct learning activities and other activities. There is also issues around resilience because of the emergencies that suffer, and there are other many issues that still need to be resolved. And then you have the other extreme countries like Honduras, where only 4% of the schools are connected to the internet. Giga does four main things. The first one is the map that I just talked about. If you don't know the problem, you cannot solve the problem. So whenever we start working with a country, we first map the school locations and their connectivity status so that we know what's the scope of the work that we have to do. Once we know that, we overlay it with other type of information like infrastructure, ICT infrastructure data, fiber maps, mobile coverage maps, and others to model what type of technology or connectivity solutions we should be using to connect the unconnected schools, how much it will cost to connect all the schools in a country, and then use all this information to unlock funding and financing both from private as well as public sector donors and investors. We support governments with that. And then finally, we also help governments in the public procurement and contracting process to make sure that the right standards are met, the contracts are properly implemented and delivered, and that the schools actually get connected and remain connected over time with the quality that they should be getting. We are active in over 34 countries. I mostly talked about Latin America, but we are present in different countries. It's 34 countries all the way from LATAM, West Africa, East Africa, Central Asia, and beyond. And the idea is that over the next year, we'll increase our presence to even more countries. We have two main offices or centers. We have the headquarters in Geneva, where we do our financing work, our procurement work, as well as establish relationships with other UN agencies and other institutions. And then here in Barcelona, particularly, since a year and a half ago, we have our tech center. That's thanks to the support of the City of Barcelona, the Government of Catalonia, and the Government of Spain. And now I'll focus more, since we are in tech spirit as well, I'll focus on our tech work, as Giga really leverages data and technology, open data and open technology and open source tech particularly, to more efficiently deliver connectivity and more efficiently help governments do that. Here in Barcelona, it's the place or the center where we build this open source tech. It's also a place we are building or creating an ecosystem around open source tech for good. And we create and we have different programs, different activities to achieve that. Yeah, in general, what we do, we are building an integrated suite of products to better plan, deploy, and sustain connectivity over time. So we have a set of tools that I'll mention some of them now in a second. We have different products and tools that help governments through the entire life cycle of connectivity, all the way from advocacy, planning, procurement, deployment, and sustainability over time. I'll now mention four of our main products. We have a couple of others. I'll focus in four of them. The first one is the one that I already showed. It's Giga Maps. And as I said, it's the largest and live map of school connectivity. The reality is that no one knows how many schools there are in the world. If you ask that question to someone, no one knows the answer. We estimate that there are around 6 million. And so far, we've been the initiative that has managed to map over 2.1 million schools. And over 100,000 of them are reporting this real-time information. This map helps us with advocacy purposes. If you go to a prime minister and you show this map, you clearly show the parts of their country that should be connected but are not connected. It also helps us work with partners and beyond that. The second product or tool that I'll mention is Giga Meter. And it's a desktop app that schools can install in a device or in a computer in the school. It's a very basic or simple application that schools install, they register, and once that's done, schools start reporting their quality of service automatically up to 4 times a day. And that data is automatically and directly showed in the previous map. We have installed this in around 8,000. It's now, I think, closer to 10,000 in almost 20 countries. And over the next year, we'll be expanding it to more so that we are able to see what's happening on the ground in real time. The next one is Giga Accounts, and it's a web app that helps governments manage their contracts at scale. What happens now is that governments issue contracts, different providers, telcos, MNOs are awarded these contracts, and then no one knows what happens with this contract. It's really difficult for governments to know whether the money that they are paying is actually having results or schools are actually getting connected. And what usually happens is that the more remote the school, the more likely it's that either internet doesn't reach there or it breaks down and no one goes and fixes. This platform combines the real-time data that we are capturing with these terms in the contract and allows governments to see at scale what's happening with their contracts, which ones are actually being implemented, which ones are receiving the speeds and the service level agreements that are supposed to be receiving, and then start getting notifications and alerts if something is going wrong or something is not working as it should be. Eventually, here, the idea is that we'd be able even to automate payments through smart contracts and beyond, so that we can automate this process. If the terms are met, then payment goes through. If the terms are not met, payment is put on hold until the issue is resolved or solved. The next one, it's the infrastructure models and maps. As I briefly mentioned earlier, once we have the information about school locations in a country and we know which ones are not connected, we combine this with infrastructure data, fiber nodes, mobile cell tower locations, mobile coverage maps, satellite access points, and others, and we look into what would be the best suited solution to connect it. If there is fiber nearby, the recommended solution would be fiber. If there is no existing backbone or infrastructure, then maybe satellite would be the best suited project. And even look into optimization models in case you need to build new infrastructure so that you can optimize that deployment of new infrastructure to minimize costs so that you can reach the more schools with less resources or with less money. We also do other things. We have ML models that can map automatically schools from satellite imagery. You remember that spreadsheet that I showed earlier? This is the example of Sudan. When we received that same CSV file from the government of Sudan and we put it on a map, we saw that 1/3 of the schools were in the Red Sea and 1/3 of them were in Nigeria. So basically, more than half of the schools were incorrectly located. And that's something that happens quite frequently. Many governments either don't know where all their schools are or they don't have the location. They know they exist, but they don't have the location, which means that planning for them, it's fairly difficult without that piece of information. Sometimes the location is wrong, could be a few meters away or could be completely outside the country. To solve for that, we have built these ML models that look into high-resolution satellite imagery that we get from Maxar and are able to learn from patterns. Usually, schools tend to have a playground. Usually, the shape is also, there are a couple of buildings next to each other. They are bigger buildings than households. So there are a few things that these models can learn from and then use that to automatically map schools. In Sudan, we were able to map 20,000 schools through this. And we are now also working with many other governments, all the way from Senegal, Mozambique, and others to help them improve the accuracy and completeness of their data sets. We are now also looking into whether this could be expanded to other public facilities, such as health centers, cell towers, or others. We also have an initiative called Connectivity Credits. Think about them like carbon credits. And the idea here is to create a marketplace to incentivize providers to go to places that traditionally they wouldn't go to or wouldn't be profitable for them. And it's kind of like matching or bringing together these providers with different types of incentives. Because what we believe is that the most remote schools, or many of them, will be connected by small ISPs. And for them, oftentimes it's difficult to access the required funding to do that. We are now piloting this in few countries and testing with different types of incentives. One example is tax breaks. We are working with the government of Malawi, where there will be a proposal where providers could get up to 5% of corporate tax discount if they connect remote schools. And with that, we are also proving that the government eventually will save money because, of course, there will be economic development in these communities, there will be growth, and that will mean that eventually there will be more tax income. We are also working with USFs, Universal Service Funds, that are funds that are tasked to connect the unconnected or to connect everyone in a given country. So we are also looking into reversed tax collection, where instead of the way they work, it's that usually companies or ISPs have to pay 3% of their profit to this USF, and then USFs repurpose that for connectivity. Here, the way it would work, it's the other way around. If a provider connects a remote school, then they would pay, again, less to the USF. And we are also here, the last pilot that we are looking into, it's around infrastructure sharing. Another thing that happens is that sometimes infrastructure is there and it's underutilized. There are backbones that are owned by governments or others that are not fully utilized. Or maybe for the big ISPs, it doesn't make sense to connect the very small village because the profit is not enough to go all the way there. So here we are testing using credits in exchange of access to infrastructure to lower the barrier of small ISPs to access this infrastructure. Finally, the last area is that we also do other applied science and research work. And we are looking into different solutions, different areas of research, AI, blockchain, that can eventually be turned into products. Some of them are optimization models that I talked about, optimizing the deployment of infrastructure. We are also looking into deepening decentralized physical infrastructure and using NFTs to store the data that I showed earlier. So instead of having a centralized database with all schools, where UNICEF is the owner. Could we create a decentralized database where each school is represented by one NFT, and then they can use this also as a proof of identity to access different types of services or even get payments, etc. So we are looking into different research, different areas of research here in the center in Barcelona. Coming back to what we do at the center here, we are in Calalié, by the way, in Poblenou, close to the 22 Arroba neighborhood. We've been there, as I said, since around a year and a half ago. We build these GovTech open source connectivity solutions. We do the research that I just talked about. We'll also be launching an accelerator that will look into solutions, tech solutions that could help accelerate connectivity, so that we don't have to, or we don't necessarily build all of them, but there are other teams also working and building different solutions. And then finally, looking into the ecosystem building, we have different programs. One of the main ones is the Government Technology Exchange Program. We've had 2 editions this year, one in May, one in November, where we are bringing to Barcelona delegations from the countries where we work for a week, so that in one hand, they learn from the work that we do, they learn from our products, they get familiar with them. They also learn from the innovation ecosystem and tech ecosystem in Barcelona and in Spain in general, and eventually they can create a community of practice when they go back to their countries to help us accelerate or advance our work. We had the last one, as I said, in November, where we brought a Latin American delegation, countries from Panama, OECS, Brazil, and Honduras, and then the previous one was in May with countries from Sierra Leone, Botswana, Bosnia-Herzegovina, and we'll be doing more of them next year. And yeah, the last slide before I open it up to the audience for questions is that we are a pretty rare, unique team within the UN. You wouldn't expect probably to have a UNICEF team presenting in a conference like the one today. You would also not find such team, but we are a team of almost 30 people here in Barcelona, technologists all the way from developers, product managers, designers, scientists, and beyond, from all over the world. So we have 16 nationalities among the 26 people that we are based here. Yeah, with that, we have, I think, a few minutes left in case there are any questions from the audience. Thanks.
Something, if I'm allowed, while I see if anyone asked, and as we've shared sometimes conversations about Giga, I wanted to ask you, and you were talking about how do you map schools, we use the satellites and all that, but how do you know that that specific thing is a school? I mean, what elements do
the components of the school?
You try to determine that that's school? We
don't predetermine that. It's the machine, the one that learns that, and it may even look for things that we are not able to catch on our own. But I briefly mentioned it earlier, it's playground. So usually there is a playground where kids play next to the building. Usually the roofs are squared or U-shaped. Okay. So there are particular shapes that are unique to schools.
But is it the same as school in France that in Sudan?
In that sense, they are different. We are also testing and playing around with that. So we have both national models that are trained with data from a given country. And of course, we also train it with other public facility data to make sure that we don't mix, industry buildings with factories with schools. And then we are also now building regional models that can be trained with a couple of countries and then applied in other countries. And then we are testing with a global model, but they look different.
Okay, let's see if there's anyone in the... Okay, we've got a question there. Let's see if the mic, we've got here all the lights.
Hello, Joram Elgoin from Higher Education Research Strategy Consulting Company Series. My question is, do you also look at the impact on the broader communities? So is the school a catalyzer to bring internet to the community? And I say this because we work with a university in French Polynesia, and where actually a research center was a driver to connect a cable from Hawaii to French Polynesia through Edurome to bring internet to the entire community. So is it often also like this, that the school is a driver to digital access to the communities?
Definitely. And Giga, it's not an education project. It's about education, but goes beyond that. Because as you said, when you connect a school, the impact you have goes beyond education and beyond the school. We did a study with the Economist Intelligence Unit a couple of years ago, 2 or 3 years ago, where we did exactly that, looked into how much would the GDP of a given country grow or increase if you were to connect all the schools in that country. And we were able to show that in countries like Niger or Sierra Leone, where many schools are not connected, it could grow up to almost 20%. So definitely. And we are proving the same thing in Malawi now with the Ministry of Finance, saying you'll give a discount in taxes for companies to connect the schools, but eventually you'll make more money because the impact will be greater. There will be new businesses that will be created in these communities that will end up paying taxes. So definitely.
Thanks.
I think we've got another one over there. Yeah, just in the back.
As far as I understood, you want by 2030 to have the whole world connected, but there are still many, many, many countries missing. What's the program? How are you selecting the countries? And what are the main issues you look for in order to establish this program?
That's a great question. We have a set of criteria for us to be in a country that also has changed. So in the beginning, we started with the Eastern Caribbean islands, with West Africa, Central Asia, to also have very different types of countries, because the challenges depending on the country are very different. It's very different, a landlocked country versus an island versus a huge country. So we started with that. But now definitely for us to be in a country, we need high-level prime minister or at least ministerial level buy-in and willingness to work with us, because otherwise it's really difficult to get things moving. Digital transformation and connectivity should be also a priority for that country, which I would say probably now it's a priority for almost any country, but definitely should be there. And also from our UNICEF offices, etc., connectivity should be some of the priorities for them for the coming years to make sure that there is traction. On the challenges, there are many challenges, and one of them, I would say, is that governments can change, and that sometimes create issues both for us, but also within the government to continue some of the programs. There were, and I can give thousands of examples, but in Colombia, the government changed, and then they decided to cut the budget for school connectivity, which meant that many schools, thousands of schools that were connected, suddenly they shut down when infrastructure was there. Niger could be another one where we were spent quite a bit of time in Niger. There was a coup, and then we had to stop working there.
Okay, so maybe we have time for one more question, maybe, if it's a fast one. I don't know if there's anyone in this. I cannot really see it, but I don't see it.
I think it's good.
Okay, so Naroa, I think we've got it with this. Just the last question. I don't know if you said it because I was coming in and out. How many schools did you map so far?
Over 2.1 million.
Whoa, 2.1. And it's amazing that many places like Sudan, as you were saying, or Colombia, I think sometime you explained me, they didn't even know where their schools are. 30% of their schools were like disappeared.
Or they are somewhere else, exactly, which might seem, it's strange, but it's a reality.
An amazing project. Thanks. Thank you very much to Giga-UNICEF and to
so
Naroa. Thank you.